Okay, we're going to talk about how to measure a surface profile. It's usually going to be from dry grit abrasive blasting. It's one method used to remove rust, meal scale, old coatings, and other contaminants from the surface. There's another method that is used a lot of times, especially like in plants or in areas where they just don't want a bunch of grit flying around and interfering with workers and machinery. It's called a bristle blaster. You can get a surface profile on it, but you're not going to get the same type of an angular surface that you're going to get from abrasive blasting media. In a high pressure hose, blowing it on a surface at a high rate of speed. This is, bristle blasters, pretty much a secondary method. Here's a close up of what a surface that has been abrasive blasted looks like. What we're going to determine is how to get the measurement. Now the measurement is going to go from the peak to the valley. You got your media that's blown in here at high speed. It's going to create this surface that's going to be rough, so that the coating can adhere to it. Coating adheres to surfaces like that much better. Take for instance, if you tried to paint on a piece of glass. The glass is very, very smooth. You can peel it off really easy. But if you go to paint on something that has a rough surface, it's gonna adhere a whole lot better. That's one of the main reasons why we do abrasive blasting, and we get these profiles. And that's going to be the same measurement we're going to get with a bristle blaster as well. It's just you're typically not going to get as much. Some of the manufacturers say you can get more than what I've seen them get. But I mean it's really the company's preference whether they want to use a bristle blaster or not. Okay, I'm going to demonstrate how to get a profile reading off of a blasted surface using two instruments. Now the number one instrument we're going to demonstrate is it's a dial micrometer. It's also known as a spring micrometer or an anvil micrometer. The number two instrument is going to be the DeFalco replica tape reader. So to demonstrate this, we're going to use a training tool that comes in a kit with this instrument if you choose to get the kit that has the training tool in it. But what this does is it allows you to develop your burnishing skills to the point to where it gives you an acceptable reading. This thing actually has little serrations on the back. We're just going to take one of these Test Espresso films. We're going to center it on the serrations like so. Then we're going to take the burnishing tool and we are going to go ahead and burnish the surface using either a circular or an XY pattern. Rub firmly. Make sure you get a good solid impression of the surface. Now you're going to do this to your blasted surface. Now before you use it on a blasted metal, they want you to use this putty on the surface to clean it. It's really just a 3M putty that I got from DeFalco. It's just going to get the dust and it's going to get the blast media so that our tools don't end up having interference whenever it goes to read. Now this particular micrometer has a dial on it. You can start it at 0. Now this tape, since the tape is 2 mils thick, your final reading you're going to have to subtract 2 from it. So if you take a reading on this and it's 5, you're going to subtract 2 mils. Or you can just dial it back from the start. You can just dial it back to 8 from 0. That's taking your 2 off. And then go ahead and center your caliper in the middle of the film, and we got 3.1. Now this tool tells you that you're looking for 3.1 plus or minus 3/10 of a mil. So anywhere from 2.8 mils to 3.4 mils would have been acceptable. This is perfect right here. So since we got that, let's move on to our replica tape reader, and we're going to demonstrate in similar fashion. Now here's a few settings on this that you're going to want to set up to begin with. One of them is every time it comes on, you're going to want to press these two buttons together to give you a 0 reading. Zeroes it out. We have it set to extra coarse tape. You're going to want to make sure you got it set for the right tape. It'll probably tell you if you got the wrong tape in there. So we'll go ahead and put that on there. We will burnish. Now, the Presso film manufacturer says that you can use the corner of their little case that the film comes in a pinch. I've seen people use, like your end of a pen, just a little to do that with. Now I haven't seen where the manufacturer actually recommends that. Let's see what we come up with on here. We're going to go ahead and zero it out again, just so. Start over fresh. All right, let's see what we get. 3.3. So now remember, we can get up to a 3.4 and still be there. So 3.2. I mean, we're looking for 3.1 plus or minus 0.3. So that's an acceptable measurement right there. The thing that I'd like to show you as far as like these Testex tapes, because what happens is that if you need them to put on a report and you don't put this tape back on something that's going to preserve the sticky substance on the back, it ends up getting contaminated with dust and dirt and whatever, and then it won't stick to the report. So what you're going to want to do is you're going to want to stick it on something that has a repelling surface, like a plastic book back or something like that. And I'll write the weld number if there was a weld, and then I'll put the profile reading on it. If it's a bigger structure, I might have to use a numbering system where I put a 1, and then I'll just have a notebook where I have a reference where it goes to. But that's just something to preserve these films if you need them for documentation later on.